Good morning, everybody. My name is Lav Savir. As Monica mentioned, I'm the founder and the CTO of AllCloud. I'm excited to have Idan with me this morning. Good morning, Idan.
Good morning. Thanks, Lav, for having me. And excited about the partnership and the opportunity to demo our joint offering.
Exactly. Right. So, as a reference to everyone, why we talk about platform engineering and what is this, what is all about. We want to give you a hint of how we see platform engineering evolving in the ecosystem, what challenges are customer facing, how we help customers to overcome these challenges. As mentioned, feel free to shoot questions throughout the session. We dedicated some time at the end to answer them. And let's go into the details. So the agenda, we'll discuss what platform engineering is all about, where is the industry going with that. We prepared a very interesting demo of how we envision and see a developer experience happening. And then we'll discuss more about the offering, and as mentioned, a Q&A again. So I think we should all start from the reasons of why platform engineering has evolved. And like any solution, it starts from a challenge, from difficulties that are happening in the ecosystem. So the number one issue that platform engineering is aiming to address is productivity. If you look at the researches out there, you will see that significant part of the developers' time is invested in keeping infrastructure healthy, which is by definition away from what developers meant to do initially. And we definitely want to address the productivity challenge. Another key area that is facing always a challenge is security. And security many times happens because of misconfigurations and human mistakes. And by standardizing our application delivery and workload deployment, eliminating the ability for human mistakes, aim to reduce the blast of the security poacher, and definitely take the result of human mistake errors to a much lower number, and again, improve security overall. Last thing is the quality, because we do things over and over, and not every piece of DevOps code gets mature enough. There are many quality issues happening over the CI/CD pipelines, over the infrastructure deployment. And again, because we standardize, we overcome the quality issue. We are going to provide a much stable environments just because they're standardized, and those blueprints are a lot more mature. So what is, the philosophy of platform engineering? And actually, I found a quote on the Microsoft site. So platform engineering aims to improve the whole development lifecycle. As mentioned, improve security, compliance, reduce cost. Because we build things very intentionally, we will reduce cost. We will definitely reduce the time to value, because you do not need to reinvent the wheel every time again. You use the ready-made capabilities, will improve time to value. Definitely, developer experience will be improved by making those blueprints available to the developers, not through the DevOps. The idea is that developers themselves go to a self-service catalog, and we encourage self-service as much as possible, and launch their environments, launch their application capabilities right from directly from the self-service console. And then from that point on, they will always go and put their code inside. So I think it's a critical thing. It's a mind shift and a new tooling. But eventually, the way I see it is a relative, an evolution of the whole DevOps engineering and platform engineering. So another data point I think super interesting I found on Gartner. Gartner believe that 8% of software engineering companies and organizations will adopt platform engineering by 2026, which is eventually very soon. And the main point there is to focus on reusable services, reusable capabilities that the platform engineer, which is an evolution of the DevOps, will be available to each and every developer to do their work. This is definitely something we see happening, I think, in different shapes and forms across multiple organizations. And what we try to do, we also try to standardize this journey into platform engineering, provide you with all the tooling and the processes, which is super important, to be able to achieve it. I think when we talk about the platform engineering, it's important to embrace the approach. What are we trying to do, and how it is going to work? So the number one thing we will work with you is about standardizing. And by saying standardizing is, let's say you have your set of environments that you set on an ongoing. You develop different microservices for a particular environment. And these microservices could be, have multiple occurrence over different environments. So the number one thing is to standardize what a microservice look like, what an environment look like, even the databases, the RDS, that even an S3 bucket, how we standardize, how we bake in the encryption, how we bake in the auditing, the logging, the access. Just by standardizing these aspects, we get a very high quality. So number one thing is standardizing. For me as a developer, a microservice, I have a scaffolding that where I start from. Second thing is self-service. We believe and we aim that the developers does not need to rely on the DevOps directly. They should consume their infrastructure pieces, any of their needs for the development directly from a self-service portal, from what we know in these days called the internal developer platform. They should go directly, self-service, pick up what they need and launch it towards where the platform engineering team designated for them the development or the environment they want to launch into. Everything has to be automated. We intend to remove all the ClickOps from the journey. And the idea is that once we automate from the initial setup of, let's say, your Git repository, your IDE setup on the development environment, throughout all the pipelines and all the infrastructure behind it, everything is going to be fully automated, and that's key. And the last thing is the integration. We are, with platform engineering, we're integrating all the tooling together, from the Git repository to the pipelines to the environments, all these tests and verifications and steps in behind, all will be fully integrated together to a very complete experience. It is important to emphasize how platform engineering works. And again, I decided to look how Gartner is positioning it. I think it's really interesting from a very high level how they see it. The whole idea is that today we have the infrastructure, and it's fairly complex, and there are many platform capabilities available today on AWS, on any other cloud platform. But what platform engineering does, it basically encapsulates your ongoing workflows. So the number one thing is reusable components. It gives it to you as a service, a set of tools that is being made available to you either as an environment as a service or through the developer portal. And of course, documentation is critical. Each and every of these blueprints has to have their own documentation in the right context for the user to be able to leverage them and make an efficient use of it, and also give continuous feedback. And at the end of the day, what platform teams meant to do is to make these tooling available directly to the product and the service teams, so they can go and consume it in a very clearly self-service approach. A common question that is rising is, so what is the difference between DevOps and platform engineering? So DevOps is basically where we all started, the journey. We automate everything. We try to put everything in pipelines and infrastructure as code. But eventually, it was never been standard. So as you can see on the screen, on the DevOps, there were one product team who built their environments from different infrastructure as code, their own tooling capabilities, and it wasn't very standard, and they were fairly isolated and not sharing enough capabilities between them, even though in many cases, organizations started to share and started to reuse capabilities, but there was never been a concept of standardizing as an objective. In the platform engineering, this is where the change happened. We do have our unified infrastructure, whether it's on-prem or in the cloud, but we also have the platform tooling, which is the entire build processes, tests, releases, all the deployment, monitoring, all the operational tool are baked into the platform tooling as blueprints, as a repeatable pattern. And each and every product, team, or function basically consume from the product. The idea is that the platform team will establish a set of blueprints for the product teams to build. They'll always be continuously updated and changed and modified for the need, but definitely from the foundation of them are very highly used. And what we see today, the way we measure the success of blueprints is actually through the reusability. How many times the blueprint has been reused across multiple environments, across multiple products. This is the indication whether we made it right. But also, there's a conflict between making it super generic, then it becomes super complex. There's always, a balance need to be taken between how much you complicate the blueprint versus simplified. But you'll see it, throughout your development of platform engineering and how to balance between the two. But I think the number one concept to remember is standardizing your deployment frameworks. Important thing to remember when we talk about platform engineering is how does it fit to the cloud operating model? We have been in this ecosystem for quite a while, and the way we see today how cloud operating model works well is that there is a dedicated team for the whole security aspect of the environment, which is the landing zone team, which are owning the security baseline of the cloud environment. These teams are normally separated from the platform team because the platform team has a different mission. The platform team has a mission to provide highly reusable blueprints or patterns and make them available to the different workloads or product teams, basically to run them and own them. So by the platform team providing, let's say, a Kubernetes, an EKS setup just as a platform, and the developer themselves go and launch a different microservices self-service through these internal developer portals into the platform. This is how they become really owners of their workloads without having the underlying platform. And imagine how efficient it is that there are very structured ways of managing Kubernetes clusters at scale across organization, and developers need only to focus on their application. I think this is where it becomes very powerful, and this is what we try to do. So we are already baking platform engineering into the cloud operating model, and we are seeing very good success of these layers and roles and responsibility separation across customers. If I need to kind of a quick summary of the benefits of platform engineering, definitely operational efficiencies, saving a lot of time, of unnecessary time invested in doing repeatable activities or unnecessary activities by different functions. Most important is developers. Developers should focus on creating business value, implementing business logic, and the algorithms, or even data scientists or data engineers. They never meant to create and operate an infrastructure. From a cost optimization, definitely we see significant cost reduction because once you standardize your deployment, you are very confident at the end of the day even determine the environment and save the cost of the unnecessary existence of these environments on the cloud. Just terminate it at the end of the day, or let the platform terminate it at the end of the day, because it's unnecessary. Seeing a significant cost optimization because you do only the things that are required and you're not worried to turn them off. From a security, that's key because human mistakes, we're all seeing it happening a lot. And by standardizing those repeatable patterns, verifying them in advance and maturing them over time, and embedding the standardization into them, what kind of encryption we want, what kind of auditing we look for, how is the access set to these environments, least privileges. Security is by far enhanced leveraging platform engineering. And of course, time saving and time to market. If I do wish now to go and launch a new capability, or let's say we'll see in a couple of minutes, just a couple of lambdas, I want to launch the platform, but make it in a standard, fairly, production ready environment. I don't want to be in a position to set up all my pipelines and bother about this, and a lot of setups that are required. Time to market is significantly achieved through platform engineering. And of course, reliability, because we are baking all these capabilities right into the blueprints. The reliability and scalability is baked into them, is thought in advance. We don't just start something quick and dirty and then see how it goes, because those blueprints are built in advance. The reliability and scalability is already baked into them. Overall, we see a lot of benefits. I'm sure there are even more that I didn't mention that you will find out throughout your journey. I want to give you, a hint of what are we offering jointly with Quali from an AllCloud point of view. We provide customers who want to make their journey to platform engineering is an essential blueprint package. Over the time, we created a lot of blueprints that we are making available to you as customers, so you can simply make an immediate use of the blueprints we created. By the way, they're all AWS blueprints. That's where we focus. So we make them available to you. There are also self-managed blueprints. You can create your own blueprints in your own environment. We just give you a full platform developer environment. The whole blueprint lifecycle solutions from an IDE to the different versioning and Git flow behind it. Definitely everything is cross-account, cross-region capabilities. We are using 100% AWS native services. Everything is hosted with your environment. We host nothing for you. It's just everything implemented in your dedicated Amazon environment. We also provide some interesting reporting analytics views to you, so you can learn from the usage of the blueprints that you created. As we said, one of the key success KPIs for platform engineering is the indication of reusability. We want to make sure that things are being reusable. And we also offer to you, full maintenance by us. Together with that, we partner with Quali because we were looking for an internal developer platform, which you'll see in a minute by the demo by Idan. But generally, Quali provides a very good environment as a service framework where you can manage environments which are a result of blueprints and launched by self-service to developers. A clear blueprint modeling framework, how you model and how you assemble blueprints into environments. Full self-service portal integrated to your IDP, to your entire security framework. Very good cost visibilities and insights. a full life cycle of the day-to operations, from drift detections, running updates, and even running custom actions, custom operations. You want to take a snapshot of your EBS, you want to restart, you want to do different activities. Everything is baked into the self-service experience. Very strong policy engine in order to define access patterns and a full role-based access environment. Fully integrated to AllCloud blueprints, and it also offer the heterogeneous infrastructure as code. You can run either it's a CloudFormation, Terraform, CDK, your own flavor of OpenTofu, whatever, from within Quali. So altogether, that's how we help customers to onboard to platform engineering with the tooling and the processes behind. I do want to pass the session now to Idan to walk us through a demo of a very simple use case, which we see a lot is a developer wants to deploy a Lambda just in a few clicks, but doesn't want to do it, quick and dirty, and just coding directly into the console, which is not a very good practice, but have it, a best practice with a pipeline behind. But it seems too simple, so simple, but once you put it behind, a blueprint, it is becoming really a streamlined process. I'll pass it over to you. I'll stop share and pass it over to you.
Thank you, Lav. Hi, everyone. I'm sharing my screen. Please let me know. Can it be seen?
Yeah,
same slide? Excellent. So as Lav turned it over to me, we'll show you a relatively simple example of how can someone take the Lambda function and streamline it. We want to show you infrastructure and application, CI/CD, and go over the creation of a new application or service and to see how we can scaffold the DevOps process, meaning creating the repository, the required pipelines, and the actual deployment of those Lambda function, meaning that it treats both the inner loop processes and the outer loop process management. In the demo, the focus will be more about the creation, but we'll also see the updates, meaning how can someone change the application source code and how that is being pushed both for the dev purposes and then to production. And we'll show an illustration of how can infrastructure be changed and added, because over time, the owner of the service, the developer, can basically add, remove, and make changes both to the application, but also to the infrastructure. And just before turning over to the product, then I'd like to show some sort of flow of what we're going to see. So I'm going to act as an application developer in some sort of organization where I'd like to go and start, and obviously to choose from a self-service catalog to create a Lambda application, my new Lambda application. Behind the scenes, there will be building blocks that in the form of blueprints that will create the repository, specifically a TypeScript template in code commit, and then turn over, and the process will create two pipelines, one for dev, one for production, with relatively two functions for dev and prod. But obviously, this can be deducted, and any organization can take it in terms of methodology, whether it's branching methodology of dev, test, staging, production, or repositories, and project what we're seeing here to the organization methodology. So with that, I'm going to stop the presentation and turn over to the product. So just for orientation, what you're seeing right now is Torque. a SaaS multi-tenant offering. And I'm here in the AllCloud account. And I'm going to act again as a developer and think about a platform team that prepared a lot of building blocks and all kinds of procedures that help me with my day-to-day work. In this case, I would like to create a new Lambda application. Now, this catalog was set for me, for my team, for my business unit. And I know that I want to create a new Lambda application, so I can basically get additional information about it, make sure that this is what I want to do. This is my activity I want to perform. And I'll choose to launch it. I can give it my service some sort of name where I have already one with this name, so I'll just give it a random number at the end of it to indicate the Lambda function that I'm going to create. Next, I'm going to be required to enter a few parameters. Here is the application name. Again, I'll give it the exact same name that I want my logical service and the actual service to be named. I have the templates in my organization. There are several languages that a Lambda application can have, so I'm going to choose TypeScript here. And there are all kinds of additional inputs that are specific to the Lambda function, not things that I must add here. I know that I want my dev branch to be called develop. I know that my prod branch is main. I know the platform team already set defaults that are exposed to me here that I can see. I definitely want to give a description as a good developer, and I'll use something I have here before. And also, as a standard in the organization, I can add a tag or several tags. There could be tags behind the scenes, we'll see that. But here I'm required to put some sort of tag just to specify the activity type, because this environment could be something that will be always on or something ephemeral. The platform team here required me to provide some sort of input. I'm good with what I have here, and let's click launch. So behind the scenes, what Torque does, it basically connects to the cloud provider, in this case, an AWS account. And you'll see here that things are starting to launch. We see a cloud formation that now deploys and creates a repository according to the convention, according to the organization convention, with the name that we provided to it. It's nice to see that I know how much time I have for coffee here, so I have about 5 minutes until this entire process will end. I have a complete activity feed that will be, activities will be added as steps proceed. I have a complete log of everything that's more technical. Maybe for some developers it's relevant, for some less, but I have a complete log of everything that's required. All tags, developers, end users don't need to worry about what's going to be tagged and what not. Everything, whether automatically or custom by the platform team, can be set. Drift changes over time. Once the Lambda functions are deployed, there could be all kinds of, let's say, unmanaged, unintended changes, something that is very important to understand. I'll see them here. Workflows, the ability to basically drive additional data operations on some sort of, either on the environment level or all kinds of cloud resources. So that will be available for me here. And maybe just to end this orientation of the environment, of the service that I'm now creating, is the ability to see everything once it's deployed in YAML format. So with this, I'm going to move to an already deployed environment that I launched earlier today. It's called another new Lambda application. And here we can see the environment YAML. Basically, everything that you see here is a very cool UI and should be very user-friendly to initiate whatever the consumer, the developer would like to do. But just keep in mind that everything that you see here has all the entities are GitOps in order to support changes from Git itself as files. So in this case, we see the environment as code, and basically the blueprint as code as well. So very critical for organizations, for a developer platform to have everything as code to support the GitOps processes of the organization. If I go and back to the flow of the demo. So I launched this a bit earlier today, and just for demo purposes, in order to shorten the wait time on the previous environment, then I would like to see what really happened here. So I'm going into the quick access, and the platform team prepared for me all kinds of links that are shortcuts that I don't now need to go into the AWS console and try to struggle and understand where to go. And the first link that will go is the repository itself that was created for me. So we can see here that a repository with the name of the service application that I wanted was created. I can see here that it's not empty, so I have already a starting point for me, some sort of hello world that was prepared. In the source, we can see that there is some TypeScript content here that I'm not starting from a blank repository and project, so that's great. I can start from here. However, I do see that I only have a main branch. Now, if I go and see the dev pipeline, then I can see that it's broken. And obviously, I don't have a branch called develop. So, let's do one. Let's create one. Let's go into branches of my code, and let's create a branch. Let's call it develop. And let's branch it from the main branch. And what I have now is the same branch that we saw before, with the same code from the main branch. We see things that have been fixed. So now the pipeline is connected to the develop branch, and we see that the process creating the deployment of the Lambda application has been launched. And let's wait a few more seconds until it completes, and then feel confident that we can test our Lambda application. Refresh just to verify. So in the meantime, okay, it's been completed. I'll go into the dev function, the Lambda function that was just created. And in here, we can see the Lambda function just to see that, you know, everything is correct and I can start doing my development. Then let's run some tests just to verify that it's according to what I want. Let's remove this. And that the Lambda function, as you saw, has some sort of JSON required as an input. So let's pass the query string parameters and have one parameter here. Let's give this a name and make it shareable for others to also test. And basically, let's save it and let's run it. Great. So I can see that my Lambda function was executed. I see that, you know, the process, if I go to the presentation, I see that the deployment of the dev to the Lambda function was successful. I see that the production was successful, but let's just verify that as well. So I have the prod function console, and I can basically do it from the same execution now on the prod Lambda function. And let's run that as well. And great, I see it here, which is awesome. So this basically completes like my instantiation. As a developer, didn't need to know too much about how things are built behind the scenes, connecting the repo, tying the pipelines to the Lambda functions, and do the entire CI/CD process here, which is really cool. And now let's go and you know, do some changes and basically make some changes to the function itself. I'll go to the same repo, to the source of, first of all, the develop branch, and basically do some change here. And I want to say that I was here. And basically commit these changes. Cool. And before I create a pull request, then obviously I want to verify. So I'd like to go and see that the pipeline is now being updated. So let's go to the dev pipeline link. Again, using Torque in order to get those quick access links, I don't need to go into the internals. I see that the source code was updated successfully, now waiting for the deployment of the Lambda function. Let's give that a few more seconds. Cool. So I see that the Lambda function has been updated on the dev branch with the new code. Okay, so this is my developer Lambda function, and let's run the same test. And I see the code that was changes. Great. I know now that I can run tests, pass it to someone else in order to verify. I can basically get assurance in my code changes. And once that is done, then I can basically go and merge my changes and go back to the source code. Go to my developer branch, create a pull request, and I can obviously see everything that was changed and continue with the pull request, make a simple merge, and we should see the same process that we saw for the dev pipeline and Lambda function happen for the prod. So let's just verify that's the case. We'll close a few of these and open it. The dev pipeline from here. Sorry, the prod pipeline from here. So I know that something has been changed and triggered. Source code has been successfully merged and updated, waiting for the Lambda function to happen. And I think you get the notion of how simple it is. Obviously, in the context of a sample and a demo, for a developer to initiate such a process and to basically track all the changes, because a lot of all the heavy lifting, all the DevOps platform stuff has been done behind the scenes for him. Just as a final verification, I'll want to verify that my Lambda function in production is now updated. So just to be sure, I'll go and verify the execution of it. Cool. And that basically completes the flow of creating the service initially, all the scaffolding process that has been done behind the scenes, opening up a develop branch, making code changes, verifying code changes, and then pushing them to production. So that's really a complete flow of creation and updating of code, which is really, really great and helps me tremendously. So with that, I'll move back to the presentation. And go over a few more flows and just verify or sort of make sure that, this demo that was simplified, then to basically talk about an application developer that wants to add new functionality. So obviously there will be another process that will create that feature branch for him to be able to create a pipeline and a Lambda function associated to that feature or code change from and derived from this branch to support him. So maybe some, according to methodology, work on the develop branch, maybe others create additional feature branches. Obviously, this is also supported. And code changes is something that we saw. We saw both the merge of, the changes on the dev branch. Here it's a merge from the feature branch to the dev branch. And we saw afterwards the merge from dev to the prod. And another important aspect is that it's not only source code changes that can be done through the platform, it's also infrastructure changes. In this case, just to give an example, then these are a Cloudflare whether it's for WAF purposes or load balancing purposes, I want to basically, in this case through Terraform, add to my environment that component in order to configure Cloudflare to be able to be in front of my Lambda application. In this case, both for dev and for production. And these building blocks are something that can come out of the box. And in a similar way, just to stimulate the idea, then many other ecosystem DevOps products can be added here into the environment, into the flow. And Datadog might be another one in order to configure. I want to, my service wants to send logs to Datadog, so Datadog can be configured with that service details in order to be able to streamline the logging and provide me with insights and analytics on my logs. And this pretty much completes everything that from a developer, from a consumer end user, to be able to see how, in a very self-service fashion, to be able to create my service, to make the changes, both software and infrastructure changes. And with that, I'll hand it over to Lahav.
Thank you, Idan. Congratulations on passing the demo successfully. We know it's not trivial. Demo is always risky, but you made it. I will share quickly, a quick summary of the offering and how we help you go forward with that. Let me just make sure you see me properly. All right. So what do we offer together? So I said, we're offering to you production-ready essential blueprints as a big library of blueprints available immediately for you to use right now out of the box. I mean, the underlying templates of the infrastructure as code, that's one. We know that from experience that platform engineering requires training and changes. So we are offering also a few days, 3 to 5 days instructor-led training for platform engineers and for developers, both how to work with blueprints and create them and offer them, as well as for developers how to consume them. Then we all know that each and every customer needs their own custom blueprints. So we are jointly going to work with you on building those set of blueprints tailored to you, to your needs, your environment. We strong believers on building things and getting them all the way to production, and never stop in the middle. So we are suggesting to do what we call the pilot flight. So we jointly take a couple of environments all the way to production. So we create the blueprints for them. We onboard the team to the production, to the platform. We do the whole development lifecycle all the way to production, leveraging this whole solution. Part of it is, as you saw, the Torque internal developer platform, part of the solution, and also our very advanced CDK pipeline. As big advocates of CDK for infrastructure as code, we also offer our Open Blueprints engine as the framework to create CDK blueprints. But as was demonstrated, you can do Terraform, you can do CloudFormation, you can do many, many things that is mostly suitable for your needs. But this offering meant to really put you on track to platform engineering. And with that, I will jump into the Q&A. And Idan, welcome to join me. There was one question through about why did the pipeline fail on the develop branch? Because frankly, we didn't put it into that blueprint. We could have added the creation of the develop branch to the pipeline, to the blueprint. We didn't, but intentionally, this was completely intentionally. So it was added branch created and everything flow. Second thing was, another question was about Can we now add more lambdas or add more resources to my environment? Absolutely, yes. We start for something very small, I mean, a couple of lambdas, but we expect you to add more S3, SQS, whatever around them, or even expose it through Cloudflare by just enhancing this environment blueprint. Another question that is saying, okay, what is the difference between Torque and Backstage? Good question. So Backstage is basically an internal developer portal, is the level above the platform. Normally, it has a lot more integrations. We think it's a lot more complicated. We do have integrations of Backstage with this environment. It adds value, but it also adds a lot of complexity. So frankly, I think for customers should start an easier way with less complexities and consider just going with the internal developer platform as the beginning. If you want to make the next step to the internal developer portal, that's also possible. It's a layer on top. That's another question.
Maybe now I can just add just one sentence there. There is a subtle difference, but it's not subtle at all, between an IDP, which DP is portal, or platform. In order to make Backstage a platform, you need to sweat and invest a lot. So just to give my 2 cents.
Perfect. Another question I see is this meant for development only? So the answer is absolutely no. As I mentioned with our offering, we take the whole platform engineering experience all the way from the very beginning of development to the productions. You can implement very cool workflows who allows to promote into production. But the whole idea is that the blueprints that were used in the development, 100% those are being used in production. And also this infrastructure creation happens with the same identical blueprints and capabilities. So the platform engineering meant to take you from the beginning of the development all the way to full production, including the blueprints, the pipelines, the developer platform, all together is 100% suitable for production. It has a lot of security aspects embedded to that, so you can definitely trust it and rely on it. Let me see if there are more questions. That's it, right? So thank you everyone for participating. We believe that our platform engineering is a significant upgrade to the DevOps lifecycle we used to have up until now. We invite each one of you to reach out to us, to question, to brainstorm on your journey. And if you need help or advice or the full suite of solution to your needs, we're here for you. Thank you very much, Idan, for being with me. It was a very interesting demo. And again, congratulations for a successful, smooth demo. It's not trivial.
Thank you.
Thank you, everybody. And we look forward to hearing from you again. Bye-bye.